Okay, so for Math 3, Lesson 2, we are going to be focusing on simplifying radicals today. Okay, so a couple of these are going to be pretty straightforward and pretty easy. This shouldn't be anything mind-blowing for you. If you see something where I want to talk about the square root of 144, if you know your perfect squares, this should be pretty easy, but just in case, you can break this down into, we could say like 2 times, well, this would be 72, and we can say 72 can be written as 2 times 36, and well, hey, there. I'm just going to go straight to the perfect square. Perfect square of the square root of 36 is going to be 6 times 6. So if I'm looking for pairs, right? So I can write this as, I would have 2 times 6, or in this case, 12, right? Obviously, 12 squared is 144. So that one's not that big of a deal. The reason why I'm going over this is to show you the tree chart. Remember, if we're looking at 150 now, I'm looking for two numbers and multiply together to get 150, because we might not have like a perfect square. We're going to have something left in the square root. Okay, so we can do 3 times 50. And if you want to, from there, we can go, well, what two numbers multiply together get 50? We can do 5 times 10. You can do 2 times 25, because then we can also do 5 times 2. So this is like saying we have the square root of 2 times 3 times 5 times 5, right? When we're talking about square roots, we're looking for pairs. So I can pull out a pair of 5s, and we're going to be left with 5 times, and inside we're going to be left with just 6. And that is our final answer for this problem, for the example one, okay? All right, so example 2. Now, assuming x and y are both positive, write the following expression in the simplest form, radical form. Okay. So again, we're just trying to simplify. For now, I'm going to ignore everything in front. I don't care about it. Not going to do anything. We can't simplify anything there yet. We can work inside my radical though. Okay. So if I break this down one step at a time, well, I can rewrite this. So I'm just looking at just this part here. I can rewrite this. We'd have x squared, y cubed, and under the square root, we'd have 3 times 3. Those are my prime factors. We have 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7 y's. Okay. All right. So again, we're looking for pairs. So square root of 2, we have 2 3's here. Let's do a highlighter to make this a little easier. So we got highlighter. We have 2 x's. We have 1 pair of y's, 2 pairs of y's, and 3 pairs of y's. Okay. So I can bring all of those out. And I'm going to go ahead and do that right now. So if we have x squared, y cubed times 3. Then I have 1x, and I have 1, 2, 3 y's. So we have y to the third. And inside my square root, I'm going to be left with 1x and 1y. Okay, so x, y. Okay, so we're done inside the square root. There's nothing else for us to do. We are just going to simplify all this. I only have one constant, one number, one coefficient. We have 3. We have x squared and x to the first power. So this could be x to the third power. And I have x to the third power, y to the third power, and y to the third power. So we're going to end up with y to the sixth power times the square root of x times y. Okay, and at this point, we are done. Okay, looking for pairs, bring it out. Once you have them all out, simplify that. Okay, same thing here, right? So I'm going to rewrite this. So I have 4 times x, y to the third power. Inside my square root, I can rewrite 27 as 3 times 3 times 3. I would have 2 x's and 1, 2, 3, 4, 5. Okay. All right, so looking for pairs, I have a pair of 3's, I have a pair of x's, and 2 pairs of y's that I can pull out. So just go and write that now. So we have 4x, y to the third power. We have a pair of 3's, pair of x's, and 2 y's. So we have y squared. Okay, what's left? We have a 3 and a y inside. So let's go ahead and write that. We have 3y inside here. Okay, at this point, we just need to simplify everything out in front. Okay, I'm going to do 4 times 3 is going to be 12. I have x times x is going to be x squared. And then we're left with y to the third and y squared. So another way to write that is y to the 5th power. Okay, that covers everything, right? So we have our 3, 4, our x's, our y's. Now I just need to copy this down. So we're left with the square root of 3 times y. Right, that's example 2. Okay, so example 3. So this is square roots, right? So in this class, we're going to be talking about cube roots, right? So essentially, when we have our symbol for square roots, we're looking for pairs, right? This symbol is always there, right? We can always write that 2 there. It's kind of like saying x to the first power or divided by 1 or 1 times that. We don't necessarily have to write it. It's implied. But once we start changing that number, like with a cube root, right, we're looking now, instead of for pairs, we're looking for triplets, right? If it was the 5th root, we'd look for groups of 5. If it was to the 10th root, we'd look for groups of 10. Okay, so I'm just going to break this one down. Same idea. We're going to break it down into the prime parts, and then we're going to pull out what we can. We're looking for groups of 3. Okay, so now, right off the bat, I know that this is divisible by 9, right? Because if I do 2 plus 1 is 3, plus 3 is 6. So I can do 9 times, we can say 216 divided by 9, and that's going to be 24 over here. Okay? This is going to be, 9 is just 3 times 3. And I can rewrite 24 as a couple different options. We can say 3 times 8. We can say 4 times 6. I'm going to go with 3 times 8, right? Because now I have, at least I know I can pull out a 3 at the very least. 3 is a prime number, but we can keep going with 8. So I can say that's going to be 4 times 2, and 4 is going to be 2 times 2, right? So another way to write this is, if I wanted to, I'm just going to bring this down lower. I have the cube roots of 1, 2, 3, and 1, 2, 3 threes. Okay, so again, we're just looking for triplets now. So we have 3 threes, and we have 2 threes, and we can bring those out. So we have 2 times 3, or another way of saying 6, right? 2 times 3 is 6. Okay, so if I were to say 6 times 6 times 6, we get 216. That's another quick way for you to check your work to make sure you're doing this right. Okay. All right, this one's a little simpler. We're just looking at variables, right? Just because they're letters doesn't change anything. I can rewrite this as the cube roots of q times 2, 3, 4, 5, right? I'm just looking for triplets. I'm going to have 1 with 2 left over. So this is going to say q, the cube root of q squared, right? I know those look like 9s here. Sorry. Let's fix that. All right, so we have q times the cube root of q squared, right? We can't pull any more q's out, so that's our final answer for that one. Let's get this out of the way, get the calculator out of the way. All right, so last example, last 2 problems. Let's drop down. I'm just going to break this problem up into my prime factors. So we can write this as y, and then we're going to do the cubed root of, well, 27 can be written as 3 times 3 times 3, right? 9 times 3, and 9 can be broken down 3 times 3. Then we have 1, 2, 3, 4, 5 x's, and 1, 2, 3 y's. So if I'm going through this and I'm trying to find triplets, again, I'm just looking for triplets. I have a group of 3's, I have a group of x's, and a group of y's. So my answer is going to look something like this, where we can pull 3's out, we can pull an x out, we can pull a y out, and we're going to be left with just 2 x's inside. So inside my parentheses, inside my cube roots, we have x squared here. Okay, simplify what you pulled out now. So I have 3, I have 1x, So we're going to write that, and I have 2y's, so it's y squared. Then we're going to bring the cube root of x squared, and we are all done. Okay. Okay, over here, I'm going to cheat a little bit. Right, we're asking for this cube root of 216, so I know 216, this part right here, this is going to turn into 6, right? So I can rewrite this as 8x squared. We have the cube root of 6 times 6 times 6. I'm just going to write it out to make it a little easier. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's and 7 y's. So we have 1, 2, 3, 4, 5, digging them right out of the room. Oh, perfect. 1, 2, 3, 4, 5, 6, 7. Okay. All right. So now I'm going to go through and circle all my triplets, right? So I have 3 6's. I have 1, 2, 3 groups of x. And then I have 1, 2 groups of y with 1 left over. Okay. So let's go and write this out. We have 8x squared. We can pull out a 6, 3 x's, 2 y's. We're going to have the cube root of just a y left over when we're done, okay? 4 times 8 is going to be 48. X squared times x to the third is going to be x to the 5th power. Then we have y squared, and then we have the cube root of y. Okay, that is your final answer. Okay, and that was our lesson on lesson 2 on simplifying radicals.